Whether your welding machine is electric or portable, the power source will provide either alternating current or direct current to the electrode. Alternating current flows in both directions, creating an amperage lag. Certain welding rods have been designed with stabilizers in the flux to help maintain the arc through these lags. Direct current welding machines provide a steady flow of current in one direction. The direction of flow, called polarity, is determined by how the leads are connected to the welding machine. DC plus with electrode positive is the polarity typically used for shielded metal arc welding. All the common rods used for welding on carbon steel have characteristics that make them better suited for different situations. The fast freeze rods have a strong arc force that helps burn off surface impurities. A circular or side-to-side motion can be used to build up weld, or because of the light flux coating, these rods can be stepped to provide maximum penetration. In the vertical weld position, 6010 and 6011 can be run either uphill or downhill. These are good rods for tacking up weld joints, welding metal that is slightly rusted, filling gaps in poorly fit joints, and as a first pass for good penetration. Stabilizers in the flux make 6013 one of the simplest rods to use. With a slightly heavier slag covering, try to keep the arc in the puddle. 6013 can also be run either up or down on vertical welds. For general purpose welding, 6013 produces a smoother finished weld bead. 7018 contains iron powder in the flux and low hydrogen characteristics. Except for directly under the arc, a heavy slag covers the entire weld puddle. Either running straight or with a side-to-side motion, the arc needs to be maintained on the leading edge of the puddle. In the vertical position, 7018 is run uphill. 7018 requires better rod control, but does provide the strongest welds for heavy stress situations and also the smoothest welds for ornamental type projects. Welding rods are available in different amounts, and it's a good idea to have both fast freeze and filler rods on hand to light the arc, bring the rod back, and start the puddle. Maintain a uniform arc gap with the amperage set high enough to let the puddle spread out. The molten metal follows the heat. Make sure you're filling in along the edges to avoid undercut. Add a little extra metal to the puddle before pulling out, back past the rod and the light, focusing directly on the molten pool. Watch the edges and the weld buildup, constantly analyzing how it's flowing out and how fluid it is, making slight adjustments when necessary. When the amperage is set too low, the puddle only forms under the rod. Increasing the amperage generates enough heat to form a molten pool. Along with starting to get penetration, this is where you begin to have control of the edges of the puddle and the weld buildup. Watch the puddle. You're looking for it to flow out to the sides of the rod. When the amperage is increased more, the molten pool penetrates deeper and spreads. Eventually, the filler metal becomes so fluid and agitated you can no longer control it. Experiment with the amperage setting. For good penetration and smoother welds, you want the amperage set as high as you can while keeping the molten metal from becoming too fluid to handle. The entire puddle is visible with 6010 or 6011. Slag covers the top rim of 6013, but the molten metal is still visible on the sides, and the puddle should move easily with the rod. With 7018, slag covers the entire puddle, but you still want to see it flowing out to the sides, with the slag solidifying back from the rod. During the weld, the filler metal is actually solidifying underneath while the slag stays molten. In the horizontal or vertical position, the slag can run or drip. Don't let this fool you into thinking the weld is too hot. You'll probably need to experiment more to set the amperage for 7018, but you will get better results running a little to the hot side. When the rod is held more perpendicular, the molten pool forms and spreads quickly, allowing a faster travel speed to limit penetration on thinner metals, deposit less metal for a smaller weld, or flatten the bead in a bevel. As the rod is angled, some of the heat is taken off the metal. A slower travel speed can be used to build up a crowned weld bead. If the rod is angled too much, the metal won't get hot enough. The molten pool will narrow, the bead will stack up, and you'll lose control of the edges of the puddle. On most weld joints with a good fit up, you want to maintain a consistent rod angle to produce a uniform weld bead. In some situations, though, you may need to vary the rod angle during the weld. To fill a gap in a weld joint, the rod can be angled more, slowing down to deposit more metal, keeping the buildup uniform, then angled back up to finish. You want to travel at a speed that keeps the molten puddle the same size. Watch the puddle. If the travel speed is too fast, the metal doesn't have time to melt, so the puddle narrows. If the travel is too slow, the metal gets hotter and the puddle spreads. Depending on the rod, the filler metal may flatten out or stack up and roll. Always maintain the size of the puddle with the travel speed. Shielded metal arc welding machines use a constant current power source. The amperage is set with the voltage varying to maintain the arc. This is difficult to measure, but a medium arc length is used to build up weld. Shortening the arc reduces the heat, cooling down the weld puddle. Try using a shorter arc gap on vertical up with 7018 when you want to build up more weld. Slightly lengthening the arc causes the heat to increase, spreading the puddle out, and is used with a more perpendicular rod angle for making smaller beads or flattening the weld on heavier metal.